Hi everyone, this is Mr. Beckstrom. Today we're going to talk about logarithms and exponential equations and how to use those to solve equations. So the first concept I wanted to show you was that if we have a situation where we have two logs with the same base that are set equal to each other, then we can let the arguments of each of those bases also equal each other. So if we have log base a of m is equal to log base a of n, since these bases are the same, there's nothing out front, there's no factors out front, we can just let each argument equal each other and solve from there. All right, let's go ahead and take a look at an example of this. Okay, here it says solve 2 log base 5 of x is equal to log base 5 of 9. Now we're almost there where we can use this rule above, except we have a factor out front, the 2. So as we saw, we can give myself a little bit more space here. Well, pen, and we can bring this 2 here. Pen tool. All right. And we can take this 2 right here, and we can bring it out to the argument as an exponent. So we're going to have log base 5 of x squared is equal to log base 5 of 9. Now since we have the same logs, and oops, put this up here. So we have the same logs. What we can do is they're equal to each other. We can set the arguments equal to each other. So in this case, x squared is equal to 9. Just take the square root of both sides. And we're going to get x is equal to plus or minus 3. However, don't forget, we have to make sure that our arguments are positive. They can't be 0, they can't be negative. The argument of each of these has to be positive. The log base 5 of 9 is always going to be positive because there's a positive argument. But this one here, if we put the negative 3 in there, we'd have a negative argument, which we can't do. So this is only going to be the positive 3 here. And that'll be your answer for this one. All right, so go ahead and take a look at another problem here. Okay, here we have log base 5 of x plus 6 plus log base 5 of x plus 2 is equal to 1. So I'd like you to take a second, maybe pause the video, and go ahead and see if you can solve this. Okay, we may have been tempted to use the rule before, getting these logs on different sides of the equal sign. However, we have this 1 to contend with, and that's going to totally mess up our idea of doing it that way. So we have to use some other rules that we've learned. One of those is that if we have 2 logs with the same base that are being added together, then we can combine them under 1 log by multiplying the 2 arguments together. So in this case, we'll have log base 5 of, do a bracket here, this is going to be x plus 6 times x plus 2, and that is going to be equal to 1. All right, so who got that? Very good if you did. Let's go to the next thing. So we're going to go ahead and FOIL those 2 binomials. So this is going to end up being x times x is x squared, 6x plus 2x is 8x, and 6 times 2 is 12. Again, this is all equal to 1. All right, and next, so more room. We're going to go ahead and use our base or our logarithmic to exponential form. So in order to do that, remember we take the base, we raise it to the power, that's what's on the other side of the equal sign here, and we set that equal to our argument. So x squared plus 8x plus 12, and there we go. So this is just a 5. Next, let's set it equal to 0, and I'm going to kind of flip the two sides here. So this is going to be x squared plus 8x. And then if we subtract 5 from both sides, 12 minus 5 is 7. So we're going to go ahead and get a plus 7. And that's all equal to 0. And now we can factor this. So this is going to give us x. We need two numbers that multiply together to give us a positive 7, and two numbers that add together to give us a positive 8. And that's going to be x plus 1 and x plus 7. And that's equal to, oh, let me erase that a little bit. That's fine, just a little slash here. And this is going to be equal to 0. So our solutions are x is equal to -1 and -7. Oh, I did that again. I'll leave that one there. All right. So we need to check to make sure that -1 and -7 do not make our arguments negative or equal to 0. So if I go up here, actually, let's check the individual ones up here. I'm sorry. So -1 works, but -7 would not work for either one of those because it would make this argument negative and it would make this argument negative as well. Kind of forget about using that one. All right. So our only answer here is just going to be -1. All right, let's look at another example here. All right, everybody. So now we're taking a look at an exponential equation. We have 2 raised to the x is equal to 5. Let's go back to our form. If I do log base b of some log, here I'm not going to use the same x there, I'll use a y. That's going to be equal to some value here, which I'll call z. You can call these anything you want to. But if we use this logarithmic form, we can now convert that to the exponential form. So the exponential form will be the b is b raised to the z is equal to y. So remember, it's the base raised to the number or value or expression on the other side of the equal sign, and we set that equal to the argument here, y. So here our b is going to be in this form 2. Our z from this form is equal to x, and our y is equal to 5. Our y is equal to 5. So I've identified all of my variables from this exponential equation, and now I'm going to convert this into a logarithmic form. So remember, so if we go back up here, since these are equivalent, I can go either way, this is going to end up being log base b, which is equal to our argument, which here is y, is equal to 5, and that's going to be equal to x. So we really just solved for our x. It's really just log base 2 of 5, and just for the heck of it, because I know some of these calculators don't allow you to use a base other than e or 10, let's use the base change formula in order to evaluate this using the natural log. So I can write this as x is equal to natural log of the argument, so natural log of 5, divided by natural log of the base, which is natural log of 2. And this would be the exact solution, and then if you wanted to, you could just put this in your calculator to get an approximation, but this would be acceptable answer here. Okay, I won't make this video too long. I hope everybody has a great day. Thank you.